Hello friends, welcome to Learning SAP 2000 and we will start our first chapter, that is Introduction to SAP 2000. So before I will be jump into the software, I will be give you brief introduction about the software. So SAP stands for Structural Analysis Program, and SAP software was released in the year of 2000, so that's why its name was given SAP 2000. And this software has been launched by the company CSI, that is Computer and Structural Engineering. So this software has been widely used for designing residential building, then industrial building, then bridges, and so on. So it has a very wide application throughout all over the world, and it has a very large set of code sets available, design code sets available inbuilt with latest revision codes. So if you don't have the software, so you can get the evaluation version free for the from the CSI authorized official website. And I had also included that video that how to download evaluation version from the SAP CSI official website. So you can go through that and you can download the version, evaluation version, so that whatever the steps which I will be performed here, same you can also perform, so that you can have the clear idea about how this software works and how to get the output from this software. So without wasting the time, let's now jump to the software, and we will start the first chapter, that is Introduction to SAP 2000. In that we will be analyze and design one building. So now we will analyze this beam into the SAP 2000. So as you can see, the length of the beam, which is going to be 8 meter, and there are two type of supports which are given at the end of the beam. One is pin, that is hinge support, and another is roller support. So these two type of supports we have to assign to the beam, and then after the point load of 6 kilonewton, which is to be acting at the center of the beam. So now we will jump to the SAP 2000. So once you will be open the software, it will be opened like this. So you have to go to the file and you have to directly click on new model. So it will be opens up the new model template. So in this new model template, you have to choose the proper template. So this one is the blank template. In that nothing will be displayed here. This one will be grid only. So you will be able to specify X, Y, Z grids with spacing with specific number of repetitions. Then after you will be also use the beam template, 2D truss, 3D truss, 2D frames, 3D frames, walls, flat slab, shelves, staircase, storage structures, underground structures, and like so on. So right now I'm clicking on grid only, and this is the one template which is used very widely, so that you can configure your grid layout according to your project, and you will be able to perform or create your project standards. And before I will be click here, I have to make proper unit. So I am choosing kilonewton, meter, and centigrade. So first unit is for the force, second unit is for the distance, and third unit is for the temperature. So here there are several type of units are available at here. So I am choosing kilonewton, meter, and centigrade. And default material, you can also choose whichever type of default material that you want to be used. So I'm clicking on grid only, so it will be open another dialog box, that is a Cartesian coordinate system, and in that I have to specify the grid. So in the X direction, right now I'm keeping these values default in the X direction, Y direction, Z direction, and X spacing, Y spacing, and Z spacing. and the first grid location, that is 0 comma 0 comma 0 from the ordinate, and I am clicking on OK. So after you click on OK, the SAP will be displayed two different windows, two different views, one on the left side and one on the right side. So on the left side, as you can see, XY plane at Z equal to 12 meter, and on the right side you will be see that 3D view. Obviously you can change this view as well. And before we will jump into the modeling portion of the simple beam, let me quickly introduce about the user interface of the SAP 2000. So first, this one is our menu bar. In menu bar, you will be able to see the different menus, different commands in each and every related accordance menus. So if you want to get the commands related to the file, you can go to the file menu. Related to the copy paste, you can go to the edit menu. Related to the view, you can go to the view menu. If you want to define something, you want to define material, you want to define load cases, combinations, load patterns, then after sectional properties, you will be go to the define menu. If you want to draw something, you will be go to the draw menu. Select, you will be go for the select menu. If you want to assign, let's say you want to assign the support condition, load condition, then after assign to the group clear, then after assigning some different type of loadings, so you will be go to the assign menu. If you want to run or analyze your structure, you will be go to the analyze menu. And after analysis, if you want to get something output from your analysis, you will be go to the display menu, and from the display menu you will be able to perform your different types of options, what you want to be display in the output, that shear force, bending moment, and so on. And if you want to go for the design, so here there is a steel frame design, concrete frame design, aluminum frame design, and so on. And in the option you will be able to perform different type of options and different type of settings and tools. You will be add plugins and help. I will be recommending you that if you are very beginner to the SAP 2000, obviously follow my tutorial. You will be able to learn. And if you want to get back more knowledge, so you can click on documentation. And in the documentation, there are different type of tutorials are there, examples are there, manuals are there. So you can go like here as well in order to get detailed understanding of what kind of SAP is available. So let's say if you want to go for the steel frame design as per your country standard, so you can double click on any one of these. So it will be open a detailed authorized CSI documentation for that. So now after the menu bar, the next one is our toolbar. So here the first toolbar, that is displayed, and these are the toolbars which are used very widely when you will be working with the project. So these are the some toolbars which you will be go very frequently on the left side on the bottom of the menu bar. So now let us we will jump to the grid section, and last one is our status bar. So this one is our status bar, and from here you can also able to change your unit system. So I'm right clicking at here, and here there is option of edit grid data. Obviously you can also go to the edit, and here there is also option of so you can double click on the grid, or you can right click on edit grid data. So from here you will be clicking on modify grid pattern. So here is our grid pattern. So right now, as you can see, we have 8 meter of beam in the x direction. So I will be in the x direction, I will be use 8 meter. So in the midpoint it will become 4 meter. So mid ordinate will be become 4, end ordinate will be become 8, and grid number D don't require. In the y direction, as you can see, we have the grid of 1 2 3 4 5 like that. but we don't require right now the grid in the y direction. So in the y direction we have only one grid, and similarly in the z direction we have also only required only one grid. And as you can see here, the grids are displayed as a ordinates also from 0, or you can also display as a spacing as well by clicking on the spacing menu. So right now I'm clicking on OK and again clicking on OK. So right now you won't be able to see anything here. So I'm clicking on view and clicking on set to review and z equal to 0 meter. So you will be able to see one grid which is x equal to 0, here x equal to 4 meter and here x equal to 8 meter. Okay, now this is our grid system. So let's say if I want to be don't worry about the grid system. So if I will be go to the course, as we will follow proceeding this course, you will be able to see much more about the grid information as well. So now let us, we will draw this beam. So here I will be go to the draw menu, and here that is the option of draw frame, cables or tendons. Obviously you can use this option from here as well. So I'm clicking on draw frame cable and specifying starting point here and directly ending point at here. So it will be also display L equal to 8 meter. So here as you can see L equal to 8 meter. So this one and double escape. So this one is my one beam has been drawn. And now what is the next? Next is the two type of supports that we have to assign. So anything you want to be assigned, you will be go to the assign, joints and frames, cables, tendons and so on. So right now I want to assign two kind of supports. So at this point I want to assign the pin supports. So that is hinge support. So in the hinge support, rotation about all three axes are prevented and restraints, which has to be movement of all in all three axes are allowable. So as we can see, as I will be use this option. So as you can see in the fixed support, everything is to be restrained. So nothing is to be going to be allowable, right? So everything is going to be fixed. In the pin support, rotation in three direction is to be allowed, and moment rotation is allowed, and movement is to be prevented. And this is about your ruler support. So in the only third direction, that is Z direction, or in the selector direction, the moment, that is transformation is allowed and everything is going to be restrained. So right now I'm using the pin support and clicking on OK. So as you can see, the pin support is now applicable at here. So here as you can see, the pin support is available at here. Similarly, I will be select this, go to the assign, joint, restrain, and I want to be assigned a ruler support. So as you can see, ruler support is now assigned at here as well. Now the next thing is we have to assign the 6 kilonewton of load. So we will be first select this frame, go to the assign frame load, because of we want to load, we want to assign the load on the frame, and we want to assign the point load. So here what we will do, we will be use the relative distance. So in the relative distance, what is happening, that the strap will be considered this beam as a 1 meter. So 0 meter, 0.25 meter, 0.75 meter and 1 meter. And in the absolute distance, SAP will be considered this beam as actual beam, that is 8 meter, right? So let's say I will be go to the absolute distance and I want to assign at 4 meter, assign the load of 6 kilonewton, right? And say simply clicking on apply. So as you will be see, 6 kilonewton load has been now applicable at here at the point of 4 meter, right? So you can also see like here, and after that the next step is what we have to analyze the structural. So we can analyze the structural like go to the analyze and clicking on run analysis, and before analyze your structure you have to save your file. So I will be save, let's say beam 1 and clicking on analyze and run analysis and clicking on run now. Right now I am running my analysis with the dead load cases, so clicking on run now, and after completion of run analysis it will be displays use the next steps and simple clicking on OK. And right now the loading pattern may not be applicable properly, so what I will do, I will unlock the model and let's say selecting this, analyze, assign frame load, point load, and let's say relative distance at a distance of zero point 0.5, loading will be 6 and everything will be 0 0. So as you can see 6 kilonewton point load is now assigned. And now to display anything, so let's say run analysis. Right now it is showing me the warning. Why? Because of I had not assigned the proper material. Okay, so for the analysis purpose that one won't be required. So right now I can directly go to the display. So anything you want to be display as an output, you can go to the display menu, and here there is option of show frame stresses, and simply click on show frame cable stresses. So here shear 22 means principal maximum shear force, shear 33 principal minimum shear force, and here moment maximum 33 and bending moment minimum value 22. So let us say I want to be see my shear force diagram with show value. So apply OK. So here you will be see that shear force 4.31 at here and 4.31 at here. So let us say if I will be use directly F8 shortcut key, fill the diagram. So there is some scaling regarding that. So you will be able to see all these things from here as well. So press the F8. Let's say I want to see the moment and show the value, apply, close. So as you can see 14.63 kilonewton meter moment is generated at here, and if you will be go through the any one of the point, it will be shows the values as well, right? So this one is enough for the introductory tutorial for the SAP 2000, that how we can model one simple beam, we can assign the two different type of support condition, we will be applying the one at the center load, one loading condition, and then after we have run the analysis and we have shown the output of that analysis as well.